Good evening. Today we're going to be talking about the reciprocal rule. So the reciprocal rule is another rule that you can use to find the derivative of any given function. Some rules work out a little bit better for it, but I'll go into that a little bit later in the video. So a couple disclaimers. I cannot spell to save my life, and I cannot write straight to save my life. So if either one of those trigger you, I will try my hardest, but no promises on that. So the first thing I want to do is I just want to start off with the definition of the reciprocal rule. I'll have an attached link in the pinned comments as a pinned comment, and it will have a link to the PDF file of my notes, questions, and solutions. So for the reciprocal rule, let's say we have a function r of x, and we'll say that function is equal to 1 over v of x. So let's define what we have as our variables right now. So r of x is just the function that we will be using the reciprocal rule on. So it's just a function that we will use the reciprocal rule on. 1 is 1. V of x, it really depends. It can either just be a variable. It can be a variable to a power of any given number. So a variable to a power. Or it can be a function in the denominator. Depends on the type of question. So it has 3 different definitions. Depends on context. So with that in mind, when you actually want to find the derivative of this, I'm just going to use prime notation because it's the quickest one to write. So we'd say the first derivative of r prime, is equal to -1 over the bottom function or variable squared. And then up in the numerator, we multiply that by the derivative of whatever that function is. So that is the reciprocal rule. We can look at some forms before I go into the questions. So something that might look like reciprocal rule. Let's say we have y is equal to 1 over 5x. We have y is equal to x squared over the natural log of x. Y is equal to x plus 3 squared. Y is equal to x squared times natural log of x plus e to the x. So let's just go through these. This one right here is a reciprocal, so I'll just use r. I can make a better effort than that to write straight. So this one is a reciprocal rule, so we'll use r. This one is a quotient rule. I'll just use q. This one is a chain rule, and this one is a product rule. So this is reciprocal, this is quotient, this is chain rule, and this is product rule. So that's an idea of what the different forms might look like. So with that in mind, I have a couple of practice questions for you guys, so I'll get into those. And we can see how you would actually identify the function and calculate the first derivative. In all of my examples, I will only be doing the first derivative, just to make things go by a little bit smoother. If you want me to go into more detail later, you can always just let me know in the comments. So for question 1, we have y is equal to 1 over x. So a couple things that stand out to me right off the bat is that we know that we can use the reciprocal rule on this because it's 1 over a function. So in this case, with the variables I used, I believe I used r of x. So r of x, the entire function will be using the reciprocal rule on is just 1 over x. And then I believe I used v of x. So our function in the denominator is just x. So in this case, it's just a variable. We can just apply the reciprocal rule to find the derivative. So the derivative of y with respect to x is equal to -1 times the denominator times the derivative of whatever's in the denominator, so x. the derivative of x is just 1 over, and then whatever's in the denominator squared. So we have x times x. We can rewrite this, and we can say the derivative of y with respect to x is equal to -1 over x squared. And this is our final answer. Third disclaimer, this is my 1, this is my 7. So you don't get confused, because I think I have a couple. I'll probably use both in the video. So that's question number 1. With that in mind, we can move on to question number 2, which is the same type of style. It's kind of the same thing with math. You really just get a question in a couple different styles, and then the numbers just change, or maybe they change around the function. So for question number 2, we have y is equal to 1 over x cubed. What we can do here is we know that the function we'll be using the reciprocal rule on, since it's 1 over something, is the entire function. So that our r of x will be 1 over x cubed. And then I used the function v of x. So in this case, our function in the denominator is x cubed. So we can just apply the quotient rule to find the first derivative. So y prime is equal to -1 times the derivative of whatever's in the denominator. So the derivative of x cubed is 3x squared all over the denominator squared. So we have x cubed squared. Let's go ahead and rewrite this. We notice that x cubed squared, well, if we have an exponent raised to an exponent, we can just multiply both of those together. So we can say right here that y prime is equal to -3x squared over x to the 3 times 2, which is 6. And then we know we have x squared over x to the 6, so we can subtract that off. So our final answer will be equal to -3 over x to the 4th. And that is our answer to question number 2. With that in mind, we can also move on to our next question, which I believe is a little bit different. So for these last 2 questions, it was really only reciprocal rule, but I wanted to show you guys what it might look like if you had to combine some of the rules. Question number 3, y is equal to 1 over x squared plus 4x. And all of this is squared. So right off the bat, let's just identify our components. So the function that we'll be using the reciprocal rule on, our r of x, so to speak, is the entire function. So it's 1 over x squared plus 4x squared. Our function in the denominator, our v of x, well, that's just going to be our x squared plus 4x squared. So this is a little bit different. So when you want to find the derivative of this, it's actually a chain rule. So here, you need to use chain rule. There's really no way around it. So with that in mind, let's just go ahead and find the first derivative. So y prime is equal to -1 times the derivative of our denominator function. Well, if we use chain rule, we bring down the 2, so we have 2 times x squared plus 4x to the first times the derivative of what's inside parentheses, that is 2x plus 4. And then just close off our parentheses. All of this is over our denominator function squared, so it's x squared plus 4x to the 4th. All of these are being multiplied together, and we have an x squared plus 4x in the numerator and an x squared plus 4x to the 4th in the denominator, so we can go ahead and get rid of one of those. So our final answer would be y prime is equal to -2 times 2x plus 4 all over x squared plus 4x cubed. And this is our final answer. This is question number 3. With that in mind, we can go ahead and move on to question number 4, which I believe it's also a combination of 2 different rules. The last one was a reciprocal and chain. This one is a little bit different. But for question number 4, there we go. For question number 4, we have y is equal to 1 over 7x cubed minus x squared. See, I told you, those are my 7s and those are my 1s. I figured we were going to have one of the questions. Let's go ahead and identify our different components of this function. Just eyeballing this, we know that the function will be using the quotient rule on our reciprocal rule, not quotient rule. The reciprocal rule, or r of x, is the entire function. 1 over 7x to the third minus x squared. And we know that our denominator function, our v of x, is 7x cubed minus x squared. This one is kind of similar to the last one, except it's a little bit more straightforward. So in order to find the derivative of this one, we need to use the difference rule. So the difference rule and the reciprocal rule. There we go. Spelling is not my strong suit, but this is math, not English. With that in mind, let's go ahead and take the first derivative. Y prime is equal to -1 times the derivative of what's in the denominator. Well, the derivative of 7x cubed is 21x squared, and the derivative of x squared is just 2x. All of this over the denominator squared, so we have 7x cubed minus x squared squared. Let me see if anything can be simplified. We can distribute out the -1, but we really can't cancel anything else. So for our final answer, we'll just say that y prime is equal to 2x minus 21x squared all over, you could pull out an x if you wanted to and cancel that off, all over 7x cubed minus x squared and all of that squared. So as I was saying before, if you wanted to, I usually don't like doing random acts of algebra to simplify it down because it takes a little bit more time. But essentially what you do is you plot an x, so you'd have 2x minus 21x. You can pull out, you can plot an x here, but if you pull out an x, you have to square it because it's in parentheses. So you'd have an x over x squared. So then you would have, this x would go away and you'd have another x in the denominator. But I think that's a little bit unnecessary, so I wouldn't do that. But that's my personal opinion. And that's question number 4. With that in mind, we can do question number 5, which is our first set of actual trig functions. Just in case, at least that way you guys can see a variety of questions. So for question number 5, we have y is equal to 1 over cosecant theta. So this question is actually really straightforward if you know what the derivative of cosecant theta is. If you don't, you get kind of stuck. So if I was on a test and I didn't know it, I'd just say the derivative with respect to x of cosecant theta. This is right, but it's not the derivative. So you'll lose points, but who knows? Maybe your professor will be nice and just give you a little bit of points on that. So our function that we'll be using the reciprocal rule on, I'm just going to use r now, is 1 over cosecant theta. I would leave it like that because if you want to, you could say, well, it's cosecant theta to the -1 power. You could do that, but then you might think it's arc cosecant and it's not. So I would leave it here. I prefer this one a little bit more. And then we know that our denominator function is just cosecant of theta. Now we can go ahead and take our first derivative. So the derivative of y, there we go. The derivative of y with respect to x is equal to -1 times the derivative of cosecant theta. Negative cosecant theta cotangent theta divided by the denominator function squared, so cosecant squared theta. We can eliminate one of the cosecant thetas from this, and we can distribute out the -1 with the -1 because there's one here and one here. So we can say that our final answer, our first derivative of y with respect to x, is equal to cotangent theta over cosecant theta. You can actually simplify it past here because if you remember, cotangent of theta is equal to cosine over sine, and also 1 over cosecant of theta. Well, we know cosecant of theta is normally 1 over sine, so 1 over sine is just sine theta. So we can actually simplify this down further to say that dy dx is equal to cosine of theta. In this case, I just simplified it down because there's something that was pretty quick. If it wasn't too quick, I really wouldn't bother with it because I wouldn't want to lose time doing that. But that's question, I didn't number it. That was question number 5. I forgot to number it. All right. So, question number 6. Question number 6, we have y is equal to 1 over cotangent theta squared. Cotangent squared of theta. Big difference. Plus 1. So in case you're wondering what the difference is, what I said initially implies cotangent of theta squared, which is very much not the same thing as cotangent squared of theta. It's a play on words, but sometimes math really do be like that. Let's see if this is a trig identity, because I have a feeling it is. I don't really have them memorized, but I do have memorized cosine squared of theta plus sine squared of theta is equal to 1. So I need to get cotangent. So let's divide everything by sine. So if I divide everything by sine, I get cotangent squared of theta plus 1 is equal to 1 over sine theta, which is cosecant squared of theta. So we can say that cotangent squared of theta plus 1 is equal to cosecant squared of theta. Doesn't really matter either way, to be honest with you. It's going to be long regardless, but it looks nicer. So we have 1 over cosecant squared of theta. Let me erase this so I can identify our components. So identifying our components, we have our function we'll be using the reciprocal rule on, which is the entire function, so 1 over cosecant squared of theta. And then we have our denominator function, so I don't use d of x, I use v of x. Our denominator function, v of x, is cosecant squared of theta. It's a chain rule, and it's a chain rule because there's no derivative for this in that form. You have to rewrite it as cosecant of theta squared, and then use the chain rule. The first derivative of this will be equal to -1 times the derivative of the denominator, so 2 times cosecant theta to the first times the derivative of cosecant theta. Choose some parentheses, negative cosecant theta, cotangent theta, all over the denominator function squared, which is cosecant to the 4th theta. Let me check my parentheses. 1, 2, those finish. 1, 1. Yep, okay. So let's cancel off some cosecant thetas, and that's really all we can do. I'm going to distribute out this -1 with this -1, and we're going to get rid of some cosecant thetas. So we'll say our final answer is 2 times cotangent theta. 2 times cotangent theta all over cosecant squared theta. In case you're wondering what I did, -1 times -1 is +1, so I just ignore that. And then we have a 2 cosecant of theta times cosecant of theta is equal to cosecant squared of theta. Cosecant squared of theta over cosecant to the 4th of theta is cosecant squared of theta. And then I just kept that. So this is our final answer. And that is 6. With that in mind, we can go ahead and do number 7. Okay, question number 7 is not a trig one, which you can either think is nice or not. I mean, that's your opinion. I feel relatively indifferent towards trigs, but in my experience, a lot of professors like throwing them out on tests. So for question number 7, we have 1 over e to the 3x times the natural log of 7x. True to form, let's identify our components. That's what we've been doing for the entire video. So this entire part is our function we'll be using the reciprocal rule on, and this part in the denominator is our denominator function. I'm not going to write it out because I would like to save time on that. This one is going to be a reciprocal rule and a product rule. So the first derivative of this will be equal to -1 times the derivative of the denominator function. Well, it's a product rule. So derivative of the first function, the derivative of e to the 3x is 3e to the 3x times the second function, natural log of 7x, plus the derivative of the second function, the derivative of natural log of 7x is 1 over 7x times 7, which is 1 over x. I'll just say x to the -1 times the first function, e to the 3x, and that is the entire numerator part. And all of this is over the denominator squared. So e to the 3x times the natural log of 7x, and all of that is squared. So we'll just go ahead and we'll just rewrite this. So y prime is equal to -1 times 3e to the 3x times natural log of 7x plus x to the -1 e to the 3x all over e to the 3x times the natural log of 7x, and all of this is squared. You can pull out an e to the 3x here and simplify it down further, but I'm not going to because I have one more question and I have a time restraint on this because if I go too long, my videos get cut and then I have to re-record it. But on the solutions that I'll have in the comments, I do actually pull out that e to the x. So you can just look at that if you're wondering how you do that. So the last question I have for you guys is question number 8, which I believe is an important one. We have y is equal to 1 over parentheses x squared over e to the x. This looks like reciprocal rule, but let's write it out and see what happens. Y is equal to 1 over 1 divided by x squared over e to the x. Basic algebra tells us that y is equal to 1 over 1 times the reciprocal of this, which is e to the x over x squared, which means that y is equal to e to the x over x squared. So it looks like reciprocal, but it's actually a quotient rule. So in order to do that, the derivative of the first function is the derivative of the numerator, e to the x, times the denominator, x squared, minus the derivative of the denominator, 2x, times the numerator, ex, e to the x, all over the denominator squared, which is x squared squared, which will be x to the fourth. Let's go ahead and pull out x e to the x, and that will leave us with x minus 2 all over x to the fourth, which will be equal to y prime. And we can just get rid of that x in the numerator. So our final answer will be y prime is equal to e to the x times x minus 2 all over x to the third. And that is our answer for problem number 8. So those are all the questions I actually have for you guys in this particular video. But if you guys have any other questions or video ideas, then feel free to let me know in the comments, and I will gladly do that. Thank you guys for watching. I hope you guys learned something, and I hope you guys have a nice day.